Okay, so JavaScript is probably the most widely used language out there because it's essentially in every browser and every web page uses it. Okay. So for the most part, it's one of the few interpret languages that is pre-installed on pretty much every operating system. Just because, again, it's in every browser and every computer nowadays comes pre-installed with a browser. Okay. And so it's available on every machine. So JavaScript itself is an interpreted language. Okay. And this is in contrast to a compiled language like C++. Okay, so we have compiled languages and we have interpreted languages. Okay. And so the difference between a compiled language and an interpreted language is as follows. When you have a language that is compiled, you write your code, and that code gets fed into a compiler. Okay. And then the output is an executable. Okay, so there's also linkers and stuff, but that's not going to be, that's not something that we care about. Okay, and so depending on the size of your program, that should be L, this should be a clock hand. Depending on the size of your program, this can take a lot of time. Okay, if you're compiling something like an operating system or something, it might take you like a couple of hours, depending on the size. Okay. And what it's doing during that time is it's looking for optimizations inside of your code. It's looking for ways to improve your code to make it run faster. Okay, so if there's something like dead loops inside of your code, it can remove those. Okay. And what you get as an output is an executable. And another nice thing about compiled languages is if you want to share your program with someone, you can just give them the executable. You just give them the exe, and they can run the program. They don't need anything else. This is not the case with an interpreted language. With an interpreted language, you have your code, and the software is called an interpreter. And so what happens is you put your code into the interpreter. Okay, so let's say that this is your code. And let's say that the code itself is the following. The first line is print 3. Okay, so what's going to happen is the interpreter is going to run this program. It's going to see the first line. Okay, and it's going to say, okay, output 3. Okay, and then the next line over here, it says loop, let's say 10 million times. Or a billion times, loop a bunch of times. Okay, and so this takes a long time. Okay, so it's going to run this. It's going to take a very long time. And then when it finishes, it can do the last stage, which is print 4 or something. Okay, and then so it prints out 3, and then it runs, it waits for a while as it's doing this loop, and then it prints out 4. Okay, and because this runs line by line by line, okay, it cannot do any optimizations. Okay, whereas if we had our C++ code, okay, and it's doing the exact same thing, then essentially what's happening is during this compilation process, it's looking for optimizations. Say that, hey, this loop does nothing. Okay, this loop does nothing, so I'm just going to eliminate it. Okay, and then inside the final exe, it runs really fast. Okay, it's just 2 print statements. Okay, so this is fast. Okay, but this is slow. Okay, so we sort of build in the slowness into the program. Okay, whereas with the interpreted, we don't have that compilation step. So essentially, this printing out this 3, this one's fast, but printing out the 4 is slow over here. Okay. So those are some of the sort of key differences between a interpreted language and a sort of compiled language. Of where is this? Why do we choose one over the other? In a compiled language, you get this optimization step, and then in interpreted languages, you get your output initially out pretty fast. Okay, as long as there's nothing like this. Another sort of drawback to interpreted languages is that if you want to share your code with someone, they need both the code itself and the interpreter. So previously there was an executable there's an executable in a compiled language that we just give with someone, and as long as they're running the same architecture, then they can run our program. Whereas over here, we have to actually give them the code, and they have to have it installed. Okay, so for languages like JavaScript, that's fine, it's everywhere. But if they have something that's sort of lesser widely used, I think Java you have to install beforehand in order to use. You have to install the JRE, okay, in order to run Java programs, and that can be a hurdle for someone who just wants to run the program. Someone who doesn't really know how to use computers, they just want to be able to double-click something to run it. Okay, and there are certain sort of programs that bundle the interpreter with themselves, but then you have this massive interpreter for your tiny piece of code. Okay. But the JavaScript engine is slightly different, in fact. So we're going to look at the JavaScript engine next. Engine. So if you talk about modern JavaScript engines with someone, and you ask someone, is JavaScript an interpreted language or a compiled language? Sometimes they might say it's compiled. Okay. And so the JavaScript engine itself, it has 2 pieces of software inside of it. It has an interpreter, and it has a compiler. It has both. Okay. So what is the benefit of this? Okay. Again, here's my code. Okay. And so we'll say that our code over here is fed in to the so it's fed into the JavaScript engine. And what the JavaScript engine does is when it receives this code, it actually duplicates it and feeds a copy to the compiler. And so these 2 pieces of software are running in tandem, and in fact they're racing against each other. Okay. So let's go back into the content of our code. Again, we had something like print3, loop, and then print4. Okay. And so the interpreter itself, it's going to go through line by line. Okay, so it's going to print out 3 to the output. And then it's going to start this loop. Okay, so it's going to run this loop. Okay, and if this loop is really fast, okay, let's say that the loop was looped 10 times, okay, it wasn't 10 million, then essentially this one's going to finish, and it's going to print 4, and then it completes the program. And the last thing it's going to do is going to tell the compiler, I'm done, I won. And the compiler is going to stop. Okay, it's going to stop its processing, whatever it did, it's going to throw it away. Okay, because the interpreter was faster in this case. Okay, now let's say that this loop instead was 10 million or 10 billion. And again, we know that it does nothing. Okay, then in this scenario, what happens is the interpreter also prints out 3. Okay, and what happens is it's stuck in that loop, and the compiler, it optimized that loop away. Okay, it optimized that loop away. So this loop is gone inside of the compiler's machine code. And so what it's going to do is when it finishes and it knows that interpreter is not finished yet, it's going to run the program. Okay, and then it's going to also, because it's tightly coupled with the interpreter, it knows which steps. It knows where the interpreter is currently at. It knows that the interpreter is currently over here. So it's going to start its execution at the same place, or where that code should have been. In this case, it got optimized away. So it's gonna start at this line. Okay, so it knows that it's printed out this 3 already. So it's going to start from here and continue the execution. Okay, and so it's going to do the next step, which is print 4, and at the same time, it's going to say that I won this time, so you stopped at the execution. Okay. So you can see that inside of JavaScript engine, we get the best of both worlds. We get the first output right away, okay? But we're not hampered if there's a slow process. We get it'll switch over, it'll sort of hot swap into the compiled version if that one becomes faster. Okay, so it sort of chooses the one that's faster. There's 2 out there. The one that's used by Chrome and Node.js. Node.js is going to be a JavaScript engine that we use in this course. It's called V8. Okay, but there are other JavaScript engines. The one that runs inside of a Firefox browser is called SpiderMonkey. Okay, and pretty much most modern JavaScript engines, they work like this. If you have a really old JavaScript engine, it might only have an interpreter inside of it. Okay, but most modern JavaScripts have both an interpreter and a compiler. This process has a special name. And you might be familiar with it, in fact. It's called just-in-time compilation. Okay, so Java also has this. Okay, so JavaScript there's sort of 2 main locations that you'll see JavaScript. So the first one is you'll see browser JavaScript. So you can also have a standalone version of JavaScript, and that is nowadays the main one is Node.js. Okay, so the question is, why do we have sort of these 2 versions of JavaScript? Each version of JavaScript solves a different problem. The JavaScript inside of your browser is built into the browser itself. So if you have a browser like Firefox over here, and you want to open up so you can open up the interpreter by pressing Control-Shift, I believe I in most browsers. Okay, that will give you the inspector tool, and the one right next to it is the console. Okay, and this is essentially a full-fledged JavaScript interpreter. If I type in a command like console.log hello world, this will execute some JavaScript code. And the browser JavaScript, it has special APIs that are really convenient. And if you wanted to do those inside of Node.js, you would have to build essentially a whole browser. Okay, so essentially the browser software, it gives the JavaScript inside of the browser, it gives us special access. So it might be able to say something like, you are able to detect when the user clicks or something. Okay, or in general, just user inputs. So it doesn't even have to be a click. They can mouse over something. So user inputs. Okay, and also includes things like access to the DOM. If the JavaScript needs to make changes to the web page that you're currently visiting, it can do that. Okay, so it can change the web page. Okay, and these are very difficult for Node to do, but it's not impossible. Okay, but there are limitations to what browser JavaScript can do. Okay, there's some things that are purposely designed to be impossible. Okay, so the 2 key ones that browser JavaScript can't do is file access. Okay, and also it doesn't have access to the eval function. Eval allows you to run arbitrary code. Okay, and file access, this is I/O. Okay, so both of these make sense. You're visiting a website, the JavaScript that somebody wrote on the website, executes as soon as you visit the page. Okay, for the most part, so unless you have some type of script blocking software. That's you don't want that JavaScript code to automatically create a new file on your computer or to delete something on your computer. Okay, so browser JavaScript is sandboxed into the browser itself, so it won't be able to access your files. And similarly, it's not able to run arbitrary code, whatever code that it wants. Okay, and that's by design. So if you're able to sort of there are like $1 million challenges where if you Google will pay if you manage to sneak out of that sandbox environment. But so again, it's designed that you're not able to have these access. So again, it's not gonna say it's impossible, but it's not intended for you to be able to do file I/O, okay, or run these functions inside of a browser. And if you do want to, then you have to use Node.js, okay, because that's where so like file access is something that we want to do for your assignments. You need to do file access. So for our first couple classes, if you want to follow along, you can just open a browser, push Control-Shift-I, and use the console debugger. Okay. By our third class, you'll need to install Node.js. Okay. All right. So by our third class, you'll need to install Node.js. And again, you could just think about this as in terms of Java, it would be like installing the JRE. So you can use either version 14 or 15. I typically tell my students to get the latest version in case that I decide that they add a really nice feature and I want to show it off or something. Okay. But version 14 or 15 is fine. Okay. Oh, so we will not be using C++ add-ons. So when you install Node.js, it'll prompt you. It'll say, "Do you want to install? The C++ add-ons and something called, I think it's called Chocolatey." And we won't be using these. And I don't think they cause any type of problem if you do install them. It's just that it's a very large install, so it's sort of adding time for stuff that we won't be using. Okay. The editor that I'm going to be using is called Visual Studio Code. I don't put any restrictions on what editor that you use. So if you want to use something else, that's fine. Let's see. But Visual Studio Code is probably the most widely used one for JavaScript, at least. Let's see. The main alternative for if you want to know about another tool is I think the main competitor is the JetBrains offering, which is called WebStorm. Okay, and that's more of a full-fledged IDE. Visual Studio Code is more lightweight, and it has the ability to be extended with add-ons and stuff, whereas JetBrains has all the tools already installed. Let's see. Okay, so I'm going to quickly run this program over here. There's like a run system, and that will print out the outputs. Now, I've had this configured slightly with a launch.json file, but most commonly you won't have this initially, so I'm going to delete it and show you how to get that set up. Okay. So typically when you run a program, okay, you'll type it up, you'll click run, and you'll click run without debugging. Okay, and then it's going to ask you which version of JavaScript do you want to run this under. Okay, so you can see that it has Chrome, Edge, and these are the JavaScript environments that this machine currently has. Okay, so depending on what software you have installed, you might have different versions of a JavaScript interpreter. Okay, so a JavaScript engine. So the one that I'm going to choose is Node.js preview. Okay, and it'll run it like that. And every time I do this, it's going to ask me again. It's going to say, all right, how about this time? What do you want me to run at? And this can be really annoying. So to fix that, there's a run tab on the side, which allows you to set up a launch.json file. Essentially, this file is telling it, what do you want me to do when you click the run button? Okay, so I'm going to set up a launch.json file. It's going to say which environment do you want to use. Again, I'm going to choose the preview builds to have the most features. And then the only thing that I'm going to change over here is that this one is always going to run demo.js. I'm going to change it to be this file, and this will always run the current file instead. Okay, so instead of running demo.js every time, I want to open the file that's currently open. Okay, so I'll save that, and then I can go back to my files. And so if over here I open, let's say, right, let's go to Untitled 3. Okay, so this prints out hello 2. This is a different file, and I click run without debugging. It'll automatically choose this file. If I go back to demo and I click run without debugging, it'll automatically choose this demo file. Okay, so just some basic settings to get you started with VS Code. Okay, so for this class, I'll mainly be jumping back. Maybe sometimes I'll run the code inside of the browser. Sometimes I'll run it inside of VS Code. It doesn't really matter for today's class. We're not doing any file I/O, or we're doing any types of browser stuff. Okay, so the commands are going to be executed the same. But do keep in the back of your mind that there are some things that Node.js can do, and there are some things that a browser JavaScript environment can do. Okay, and that set of sort of features is sometimes the same and sometimes different. Okay, so into more basics. Variable declaration inside of JavaScript. Variables are declared either with the keyword let or const. There's also the variable var, which is not really used nowadays. And you can also declare global variables, which is especially bad if you don't use any keyword. So the keyword let declares a what we call block scoped variable that is okay. And const, both let and const declare a block scope variable, but const that variable declares a constant, so you can't change it. So if I say something like y is equal to something else, then when I try to run this, it will yell at me with an error. Okay, so say type error assignment to a constant variable. Okay. Similarly over here, if I do it, it'll say invalid assignment to const y. Okay. So what block scope means is that if I have, let's say, a statement over here, if true, it means that this variable x over here, its lifespan is inside of the curly braces in which it has been defined. Okay? So if I say something like, can I print x over here? Even though this Boolean always executes, when it exits this set of curly braces, that variable x is destroyed, is garbage collected. Okay, so if I try to run this here, that x is not defined. Okay? Whereas if I move this x out of into line before, and I run this, then this is fine. Let's see. So primitive data types. Inside of JavaScript, there are 6 or 7 primitive data types, depending on who you ask. You have the number. So this is your standard IEEE 754 double. Okay. So from the previous example, you should have seen that variables inside of JavaScript are dynamically typed. Okay. Meaning that I don't need to specify whether or not it's a integer or a string. The language facilitates that for us. Okay. Inside of JavaScript, everything is a double. Okay, for numeric types. Okay. So just be careful when you're using, if you're trying to do division or something, it's division with floating point numbers, not integer division. Okay. And if you want that, you need to apply some type of floor or ceiling function, depending on whether the number is positive or negative. Let's see. So we have booleans. Oh, so we have strings, booleans. So these are pretty basic. All languages are going to have these. An interesting one that Java is unique to JavaScript is the undefined data type. And so this is the uninitialized value. This represents a uninitialized value. So if I say something like let x, so x has been declared, but it hasn't been initialized. So if I print x, it's set to be the value undefined. Okay. We also have symbols. So the symbol is not discussed in this class, and it represents a universally unique number, unique value. Okay. And then there's also big ints, which are not discussed. And this represents a arbitrarily large number, integer. Okay, so if you need to represent something like 10 to the 100 or 10 to the 1000, and you need it, and you refuse to have any routing, then big int is what you should use, because if you use the number format, it'll get rounded. Okay. So that's 6 of them. The one that we're missing over here, that's sometimes considered, so depending on who you ask, null is sometimes considered a primitive and sometimes an object. Okay. So first let's go over what is the difference between null and undefined. It's strange to have a language with both of these. All right, so over here we have 3 supervisors, supervisor 1, 2, and 3. And the key difference between null and undefined is what we call semantic. Okay, so it's how, if someone's looking at this code, how should they sort of think about what you're trying to represent? Okay, so over here I have 3 supervisors. Supervisor 1 has the value none. And essentially this is saying that I have a supervisor and their name is none. Okay, their name is none. That's how I reference them. The second example, that supervisor's value is set to be null. Okay, and this is essentially saying that I do not have a supervisor. I'm explicitly saying that I do not have a supervisor. Okay, and that's also a possible scenario. Both of these are possible scenarios. Maybe you have someone with really weird parents and they named you none. Okay. And the other example with the supervisor, not having a supervisor. Again, like the topmost boss does not have a supervisor. Okay, and then our third case over here is with supervisor 3. We have a supervisor 3 value which is in a uninitialized state. So it's essentially saying that this supervisor has not been set yet. Okay, it doesn't mean that they don't have a supervisor. Maybe you're writing some code and you add that supervisor later on in your code. Okay, maybe you need to grab that data from the web or something, but you have some value in it. You need to define those variables right now. Okay, so there might be it might be in a stage of it's not been set yet. Okay, so that's sort of the key differences. Undefined is used when you're using undefined, you have to think about this value. It's essentially saying that this value has not been set yet, but it might be set sometime in the future. When you're using null, you're especially saying that this value doesn't exist. Okay. Okay. So inside of JavaScript, so there's a lot of languages out there that sort of tout themselves to be object-oriented, and probably JavaScript fits this description better than all of the other ones. And when you're working with a language like Java, and you want to create an object inside of Java, then what's your sort of first step? Your first step is that, well, I have to write a class. Okay, and then as you're building that class, maybe you build in this sort of inheritance system or something. You say something, no, this dog, it needs to. What if I also need to represent cats and dogs? So you'll build a sort of animal abstract class or something. So you have to build all this sort of system, and then when you finish building it all and it's perfect, then you can instantiate a instance of a dog. Okay, so there's sort of a lot of stuff that you have to build beforehand inside of Java, at least with the standard Java that you learn in 2.12. If you ask the JavaScript developer what is Java, they would say it's more of a class-oriented language than an object-oriented language. Okay, because inside of JavaScript, you don't need to build a class. The class system is completely optional. Okay, so if I wanted to represent, let's say, my dog, okay, I just need a set of curly braces, and then I'll give the properties that I want my object to have. Okay, so maybe I want my dog to have a name, and I want it to have some type of age. Okay, and so just like that, I've created an object. Okay, this is actually called an object literal. Okay, and I don't need the class system. Now that's not to say that JavaScript doesn't have the class system. It's not the thing that you go to right away. If you actually do need all that complex systems and stuff, then you can go about and build it in. JavaScript does support classes. Okay, but it's not the default choice in essence. And so this object, you can treat it like any other object that you instantiate. It has dot operators and stuff. So I can access the name, I can access the age. Yeah, I'll just do ++. And so this object is changed directly. Okay, so in JavaScript, everything is objects, and this sometimes also includes primitives. So first we need to define what a primitive is. So the primitive, if we go back to your sort of 111 lectures, it's the most basic level of data, the data that cannot be further subdivided. Essentially, I should not be able to say something like, I should not be able to take some string, and it should not have a dot property on it because it's a primitive. If it has a dot property for something, then that essentially says that this thing is an object and it's composed of other objects. It's composed of other elements, because essentially what an object is it's a wrapper class that is composed of other objects and primitives. Okay, and you have this sort of recursive definition. Okay, but we know that inside of JavaScript there are 6 or 7 primitives. Okay, including the string type. So because this is the sort of lowest level that it can go, then this should not have a dot operator. Okay, but if we look at some cases, it actually does. Okay, so if we run this over here, you can see that string has a length property, which essentially means that does this actually have a, is this actually a primitive or is it an object? Okay, and the numbers, let's say, the numbers, they have a toString property. Okay, so the numbers have a toString property. So is a number a primitive? Is a string a primitive? If they have these dot properties, and the answer to this is both of them are primitives, and what's actually happening under hood is a bit of syntactic sugar. JavaScript has special classes for, well, it has special classes for each of the data types. Okay, and what happens is these classes are object wrapper classes. So they turn the primitive, in this case the string over here, into a object version. Okay, so as an example, what happens under the hood, when I run this code over here, this is actually what's happening under the hood. So it's essentially takes the string, and it sees that I'm trying to access a length property of a primitive. Okay, and because this is a primitive, it knows that it doesn't have a length property. So what it's going to do is going to automatically cast this into an object version, and the object version of this has a length property. And how can we see this? So this is the MDN documentation for JavaScript, which is probably the best resource for JavaScript. I'm looking at the string class over here, and over here it says that the object version of the string, it has a length property. It also has a bunch of methods that we can use. Okay. But we're not going to use these, okay? But it has a property length. So I should be able to do that length on the object version. So what it does under the hood is it transforms this primitive string into the object version, and that has a length property. Okay. So if I run this over here, in fact, I need this entire piece of code. Then this should work. Okay, so essentially what's happening is I'm taking the primitive, I'm passing it into, this is sort of like a string constructor, which turns it into an object string, and then that has a length property, and that will be outputted. And what I'm saying is that if you don't have this, it's essentially doing the exact same thing. Okay, so it's doing this via syntactic sugar. Okay, so this casting is happening automatically. Okay, now this leads to some really strange things. To prefix this, essentially every object has a couple of methods that are all available to all objects, and one of them is the toString method. Okay, so essentially if I say something like let's say let x equals 123, and I do x.toString, this will return back the string version representation of that variable x. Okay, and this is available to all objects. Okay, so essentially what we can do is we can say something like 123.4 .toString. Okay, and this is the same way that I can say something like hello world dot length. Okay, because again, in both of these cases, what's happening under the hood is that this string constructor is being syntactically sugared on to it. And for the number, it's a number, 123.4 is being added to it. Okay, so these are the syntactic sugar equivalents. And so this is why we can write code like this, where we can have the string directly dot length. So even though this is a primitive, it gets casted into the object version. And the same thing with this. And this leads to some really weird things inside of JavaScript, especially for numbers. I want to show that this is a string. Okay, so this is a string, so there's quotes. So the console over here, it always prints out the last expression that returns back. Okay, that's why sometimes you see undefined underneath of it, because the return value of that statement was undefined. So there are some strange things. So essentially, before I did hello world dot length. So the question is, can I do 123.4.toString? Okay, and the answer to this is yes. Okay, I can do 123.4.toString. Okay, and what's happening under the hood over here is the following. So it sees this number, and then it sees a dot, and it knows that numbers, the primitive numbers, do not have a dot operator in front of it. So what it's going to do is it's going to convert it. It's going to use the number constructor, okay, to convert it into an actual numeric value. And then that this number class, which, let me see if I can pull it up. Yeah, okay, so this number class, so this is the number object class. Okay, so they call it a primitive wrapper object. Okay, so it has certain properties, which we don't care about in this case, but it has inside of it, it has a toString method. Okay, it has a method for toString. And so this is what's happening. So keep this in the back of your mind. This is going to explain the next piece of code entirely. Okay, so one thing that's really strange with JavaScript is the following. So we see that we can do 123.4.toString. And we can do 123.0.toString. Okay, this is also fine. Okay, one thing that we can't do. Okay, one thing that we can't do is we cannot 123.toString. Okay, so if I try to run this, this will not work. Okay, in fact, I'll get an error. Okay, and the question over here is why does 123.4.toString work, and why does 123.toString not work? Okay, and this goes back into the definition. The answer to this is based off of the definition of the IEEE 754 number format. What is a IEEE 754 number? What is this? Is this a valid IEEE 754 number? Okay, so we know certain things that are not valid IEEE 754 numbers. Okay, so for instance, this is not a valid IEEE 754 number, of course. Okay. So is 123.4 a valid number? Yes. Is 123 a valid number? Yes. Is 123.0 a valid number? Yes. And so the question that arises is, what is 123 dot? You can see my IntelliSense is popping up, but I'm going to hit escape and ignore it. Is 123 dots with nothing inside of it a valid number? And according to the IEEE 754, yes, this is a valid number. Okay. Now, why does this? This is the answer. 123 dot. This is a valid number. Okay. And we're going to go back to this notion over here. Okay. When I type in 123.4.toString, what happens? Well, it wraps that with a number. The syntactic sugar wraps it with a number class. So what's happening over here when I do 123.toString? Well, in this case, it's wrapping the first number that it sees. Okay, the first number that it sees. Now, when you're doing a number, of course, it's not going to wrap over here, right? Because there's more to that number. But what the number sees is it sees 123 dot, and that's a valid number. Okay. And so this is the number that it wraps. And then, of course, this is invalid syntax. So this won't work. Okay. Now, how do I fix this? I add a dot. Okay. Now this works. Of course, this works. Okay. Okay. But now a different question that should arise in your head is, well, what does this look without? How does this look without this wrapper? It's 123 dot toString. Will this work? And the answer is yes. Okay, so this is some weirdness in JavaScript. You cannot do 123 dot toString, but you can do 123 dot toString because of how the IEEE 754 defines numbers. So inside a function, there's two ways to declare functions. You have function declarations. Okay. Okay, so over here, I define a function, function1, which has 2 inputs, A and B, and it returns back the sum of A and B. And then over here, I make a function call to function 0, 1, and 1 and 6. Now, inside of JavaScript, function declarations, so function declarations are hoisted. So essentially what happens is the language does a quick, the interpreter will, both the interpreter and the compiler will make a quick pass through the first file and looks for any functions. And any functions that it finds, it moves it to the very top. So even though that these two pieces of code are out of order, I first try to call function 0, 1. Okay, this is fine. Okay, this will still print out 7. Now, function expressions do not have this hoisting property. And to define a function expression, I have typically it's done, you define a variable name, okay? And okay, you define a variable name. You define a variable name, and then you assign it a function. Okay, so I'm going to save into this function 03 a function object, and the second name is only used internally. It's actually not required. Okay, but some style guides strongly suggest for it. I don't really care that much about it. It's just used to sort of describe what this function is supposed to do. Okay, but you don't need to give a function a name in general inside of JavaScript. And when a function is defined this way, essentially what I'm doing is I'm taking this function definition, I'm saving it into this variable, which is something that is a bit weird the first time you see it. But as you get more and more comfortable with JavaScript, this is probably going to be the most powerful feature of JavaScript, the ability to take functions and save them to variables. Now, the drawback to this is when I'm saving this function to a variable is, well, it doesn't get hoisted, okay, because this is happening inline. This is happening as my code gets executed, so it can't get hoisted. And the drawback to that is that this piece of code up here cannot execute. But if I put it under, then it's fine. Okay, so function expressions, they don't have this hoisting property. But being able to save functions to a variable is really powerful, because what I can do is I can take that function and I can pass it to other functions. Okay, I can take this function, I can pass it to another function to change the behavior of it if I needed to. And we'll get back to that in a second. Okay. Now there is another way to create functions that is going to be important. You don't need to use it. In fact, I personally, I don't find myself using it that often. But a lot of people really love to use arrow functions. Okay, so at the very least, you need to know how to read them. Okay, but again, you don't need to use them if it's not your preferred syntax. Function for. And so the syntax for arrow functions is as follows. You have your defined variables, in this case, A and B. You have this fat arrow symbol, okay? And then you have your outputs, the values that you're returning. Okay, so it's going to be A plus B in this case. Okay, so over here we're defining a function for, which so a arrow function is a function expression. It's a more concise function expression. Okay. Function expression. Okay. So in fact, I'll pass in values 5 and 6. And so it will output the sum of which. Okay. So there are a couple of sort of caveats with this function, this syntax. So the syntax is, again, a set of parentheses followed by the parameters, a fat arrow symbol, and then this return statement is implicit. You don't need to explicitly say the return statement. But there are exceptions to this. If you need to do, like, I only use arrow functions personally if it's a very simple one-liner. If it needs to be more than one line, I'll use either a function declaration or a function expression, because you lose all the benefits. Because you need, first of all, you need curly braces. Okay, so you need curly braces. And then you also need a return statement. If it's multi-liner, as soon as you use curly braces, you do not get that implicit return statement. So, okay. So typically, I would say if it's a very simple one-liner, then you can use arrow expressions. That's fine. But as soon as you need more than one line, then you sort of lose that benefits, and you're just as good using a function declaration or a function expression, because it pretty much looks the same. And there's a bit of additional things that you have to sort of remember as well. And this is a bit weird inside of JavaScript. If you have multiple parameters, let's say ABC, then that's pretty straightforward. You just add a comma and you keep on adding them along. If it goes down to 0 parameters, for instance, you have the function that prints out hello. Okay, this is the function that prints out hello every time. Well, it returns the string hello, and then that goes into console.log and it gets printed. Okay, so this returns back the string hello every time. Okay, then you need this empty set of parentheses. Okay, well, that makes sense. It looks really weird to not have anything over here. Now, if you have a arrow function that only needs a single parameter, okay, then the parentheses are actually optional. So if I have something that does, let's say, math.square roots of x, okay, so if I have a function that takes in x and it returns the square root of it, then those parentheses are optional. There we go. Okay, so square root of 25 is 5. Okay, so we mentioned that we can save functions into variables, and this is really powerful because it allows us to use what we call higher order functions. Okay, higher order functions. Okay. So I'm going to keep you guys a bit longer, just 5 extra minutes for me to finish up. So higher order functions allow us to interact with large data sets. So if we have an array, okay, right, if we have an array of data, okay, and we want to apply a function like function 4 on the entire array, then traditionally you had to use a loop to do that. But with JavaScript, you can use, it has a array-based function called map, which allows you to pass in a function. In this case, I'm going to pass in function 4. And what that's going to do is going to go through each of the elements inside of this array and apply this function 4 to each element inside of there. And then it's going to return back the array, the output array, as a result. Okay. So essentially what this is going to do is this is going to go through each of these numbers, and it's going to perform the square root on each of them. And then it's going to give back the array of the results. So I should see 1, square root of 2, square root of 3, square root of 4, which is 2, square root of 5, all the way up to square root of 9, which is 3. Okay, that's the result that I get over here. Okay, so I can pass it any array, any function. So if I change my mind, if I don't want the map.square root, I want the square of them, then I can just say x and then multiply it by itself. And then this will give me a different set of array. I can change this function and it'll give me a different set of data. Okay. This is actually slightly verbose in that this function over here is not really needed. Over here, map.square root is a function. Okay, map.square root is a function. And I know that the map over here, it takes in as its input a function. Okay, so instead of giving it function 4, which is a function that performs the square root, why don't I just give it map.square root? Okay, this is a built-in function that performs the square root. And it's going to be applied to each of these. So I just reduced my code by 25%. And it still works. Okay, so I can give it the built-in map.square root function. I can give it any function. So there's this difference inside of JavaScript. There's this notion of, well, I can call a function if I use the parentheses. So if I use map.square root and I have the parentheses, this is a function call to do the square root of 3 or something. Okay, but if I don't have the parentheses, I'm passing in the definition of the function. This is the definition of square roots, and then I can use it in functions like map, which will say something. Okay, use this function and apply it to these pieces of data. Okay, and so the last thing that I need to very quickly go over is the spread and the rest operators. Okay, so inside of JavaScript, the spread operator allows us to essentially take an array of data. Okay, so the function that is typically used for is called map.max. Map.max takes in a list of numbers, and it returns back the largest one. Okay, but if you give it an array, then it doesn't know how to handle that. Okay, so it doesn't know how to handle an array of data. So what we can do is the spread operator essentially allows us to remove the square braces from an array. So if we have an array 2, and I use it like this will remove the braces, but that doesn't really make sense to use over here, okay? Meaning that this is just a comma-separated list of numbers, so I don't really want to use it over here, but I might want to use it inside this map.max function, okay? So instead of saying map.max of this array, what if I said map.max of the spread of this array? Essentially, this will remove those square braces, and then I have the same thing as in my first example, and it works, okay? So if you need to transform your data somewhat, okay, then you can use the spread operator over here to convert an array into a comma-separated list in order to match the definition. And so that's how the spread operator works. And the rest operator is very similar because, in fact, it has the exact same syntax. It's the 3 dots. But the key difference is where those 3 dots are. Those 3 dots are inside a parameter list. If they're inside a parameter list, then it's a rest operator. If it's inside of a function call or something, it's a spread operator. Okay, and so the difference between this is that if let's say that I have a function a, okay, that takes in 2 parameters, x1 and x2. Okay, now if I call this function, and I give it more than 2 parameters, JavaScript is actually perfectly fine with this. If I give it 6 parameters, this will not cause a problem inside of JavaScript. What's going to happen is x1 is going to be assigned to 1, x2 is going to be assigned to 2, and the rest are ignored. Okay, but if you want some way to capture the rest of these parameters, then we have this rest operator over here, which is 3 dots and then some variable name. Okay, and what this is going to do is it's going to say, okay, x1 is going to have the value 1, x2 is going to have the value 2, and rest is going to have an array with everything else. Okay. think that should be, there you go. So let's run this. Okay, so the output is 1, 2, an array with 3, 4, 5, 6. Okay, so that's sort of the key difference between a spread and a rest. And then we can use this, if we do it on the entire set of variables, this is typically how max is defined. Okay, it just takes that list of numbers and it converts it into an array.